Okay, in this video I'm going to talk about the orthocenter of a triangle. So basically we have a triangle that we denote ABC, and we consider the altitudes of this triangle that we denote HBH, not PH, but HB, BHB, A, HA, and CHC. So, and the theorem says that all three of these altitudes intersect at a single point, which is called the orthocenter. So theorem says that AHA, BHB, and CHC intersect the single point which is called the orthocenter of the triangle ABC. So there are several ways to prove it. So I'm going to prove using some parallel lines. So again, we have a triangle. ABC, and the altitude. So let's consider the lines passing through each vertex that is parallel to the opposite side. So basically the line passing through B that is parallel to AC, the line passing through A that is parallel to BC, and the line passing through C that is parallel to AB, like this. So let's denote these intersection points by let's say C prime, A prime, and B prime. So by construction we have A prime, B prime parallel to AB, B prime, C prime parallel to BC, and C prime, A prime parallel to CA. So because of this parallelness, we have, so let's consider, for example, this quadrilateral A, B, A prime, C, right? So let me highlight it in blue. So this quadrilateral is a parallelogram by definition. So A, B, A prime, C is a parallelogram, right? Because the opposite sides are parallel by construction. So BA prime is parallel to AC and AB is parallel to CA prime. So because it is a parallelogram, the opposite sides are equal to each other. So BA prime is equal to AC. So BA prime is equal to AC. On the other hand, we have this quadrilateral that I highlighted in green. It is also a parallelogram. So C prime B CA is a parallelogram as well. Is a parallelogram, and similarly the C prime B, the opposite sides are equal, is equal to AC. So this side AC is equal to this side. So AC is a common side in these two equalities. So all three of these segments are equal to each other. So we have BA prime equal to AC equal to C prime B, right? So, and in particular, we are interested in BA prime and C prime B. So BA prime and C prime B. So these two segments are equal to each other. So it means that B is the midpoint of C prime A prime, right? Because these two segments are equal. B is the midpoint of this C prime A prime. So similarly, by the similar argument, we can conclude that C is the midpoint of A prime B prime and A is the midpoint. So these segments are equal and equal to this side, and C prime A prime, C prime A, this segment is equal to A B prime and equal to the opposite side of the triangle. So A is the midpoint of C prime B prime. So in other words, we have that A, B, and C are midpoints of the sides of the triangle A prime, B prime, C prime. Right, so now observe that the altitudes of the original triangle ABC, so like let's say, so AHA, so since it is perpendicular to BC, it is also perpendicular to its parallel line C prime B prime. So this angle is also a right angle. Similarly, this is a right angle and this is a right angle, right? So we have AHA perpendicular to BC implies that AHA is perpendicular to B prime C prime, because BC and B prime C prime are parallel to each other. So, and similarly for the other altitudes. So we have, so basically notice now that AHA, so this line is perpendicular to B prime C prime, and A is the midpoint of this segment. So we have that AHA is the perpendicular bisector of the segment B prime C prime. Similarly, we conclude that the other altitudes are as well. So similarly, BHB is the perpendicular bisector of A prime, C prime, and CHC is the bisector of A prime, P prime. So in total we have that these altitudes in the original triangle, so A, HA, B, HB, and C, HC are the perpendicular bisectors in the triangle A prime, B prime, C prime. So in this large triangle, these altitudes in the original triangle, so the lines AHA, BHB, and CHC are perpendicular bisectors in this large triangle. So this means that they intersect at a single point, because we are like we know that the perpendicular bisectors of any triangle intersect at a single point, which I proved in the previous video. So from this we immediately conclude that AHA, BHB, and CHC intersect at a single point, and this point is the circumcenter of this large triangle A prime, B prime, C prime, and this point is the circumcenter of the triangle A prime, B prime, C prime. But this last part is irrelevant for what we need to prove, but the main point is that they do intersect at a single point. That's what we needed to prove. And and this point now is called the orthocenter of the triangle ABC. So that's it for this video.